Okay, I wanted to go through one of the questions from your homework on bearing. I had questions before, so I figured I'd just make a video going through this one. It's section 6.3, number 24. And I'm not going to write the whole problem out because you all have your textbooks, but we'll sketch out how to solve it. So it says, a fishing boat leaves a marina and follows a course of south 62 degrees west at 6 knots. So we start by drawing my coordinate axis. And I go south 62 degrees west. And I want to be somewhat accurate. 45 degrees would be like right here. So 62 degrees would be beyond that. So we'll say right here, and that's 62 degrees. And I'm actually going to move this for now. And I'm actually going to stick it up here, just so it's kind of out of the way. But that's a 62 degree angle right there. And I'll shorten this a little just so I don't run out of room on the page. And I'm told it follows a course of south 62 degrees west at 6 knots for 20 minutes. 6 knots is 6 nautical miles per hour. And I do it for 20 minutes. That's a third of an hour. So a third of 6 is 2. So I know this side is 2 nautical miles, whatever. Then we're told, then the boat changes to a new course of south 30 degrees west at 4 knots for an hour and a half. So here, I draw another coordinate axis right here. Now I find my new bearing, south 30 degrees west. So south 30 degrees west, it's less than 45, so we'll say it's right there. And again, that's 30 degrees right there. I go at 4 knots for an hour and a half. 4 miles per hour for an hour and a half, that's 6 miles. So this side is 6, and we'll deliberately make it bigger than this side just so it's obvious it's bigger, so we have a somewhat accurate picture. And I end up right down here. And then I'm told, how far is the boat from the marina? What course should the boat follow for its return trip to the marina? My distance back to the marina, and here, we know it's 62 degrees. I'm going to erase this just so I don't get confused. My return trip is right there. So I know, as far as direction goes, I'm going to have to go north and east, up and to the right. And I need to find that angle. As far as my distance, I'm looking for that side right there. And how do I go about finding that side? I have this side, I have this side. Keep in mind, this 30 degrees is not the angle in the triangle, it's that part right there. And this 62 degrees is the total angle from the axis over to here. So I can't use 62 degrees either. But I know with law of cosines, if I can get this angle, I can plug into law of cosines and get this side right here. Well, I know if this is 30 degrees, this is clearly a right angle, so that's 90 degrees. Now I just need to find this angle right here. But if we do what we did before, I have that vertical line in greenish blue, which I'll draw. I have this vertical line in blue. I have the diagonal in black doing this. I know the angle between the black and the blue is 62 degrees. The angle that I want is the angle between the green and the black, right here. I'm sorry, that's not the angle that I want. I want the angle inside here. But this angle and this angle, well, those are both vertical lines. They're parallel. That's a transversal cutting between them. These are alternate interior angles, which means this is 62 degrees. Now, over here, that makes this angle 62. And if this is 62, this whole angle in green is a right angle. If I scale it up a little bit, I now know that with that and the black line cutting through, this angle right here is 62 degrees. I need this angle on my triangle. But that's a right angle 90 minus 62 is 28. So that's a 28 degree angle. Now, I can add up all 3 of those to get that angle in the triangle. So let's see, 90 plus 30 is 120, plus 28, that's 148. So that's a 148 degree angle right in there. Now I can apply law of cosines. Let's see, x squared equals 2 squared plus 6 squared minus 2 times 6 cosine 148 degrees. 2 squared is 4, 6 squared is 36. 2 times 2 is 4 times 6 is 24 cosine 148. 4 plus 36 is 40, so it's 40 minus 24 cosine 148. I'm just trying to simplify this a little bit before I throw it into my calculator. You all know we can't combine those. But now I get 40 minus 24 cosine 148 equals 60.35. Now, to get x, I square root that. So second square root, second answer, 7.76. So this side should be 7.76. And if we look at the problem, this is 2, that's 6. So 7.76 makes sense. I did not go in a perfectly straight line, 2 and 6, which would be a distance 8. These are slightly skewed. So I didn't get fully 8 miles away, I got 7.76 miles away. So that seems logical. Now I need to find my bearing to go back. And I'm going to have to erase this so we can kind of manipulate geometrically again. But we do the same thing. I'll actually draw this in blue again. If I draw this and draw this, my bearing back is this angle right here. And now I just have to find a way to find that. Well, let's see. There are different ways to go here. And again, it's kind of up to the geometry that you know and what you can see when you look at the picture. But if I look at this blue cross up here, and then I look at that blue cross down there, I have the black line going from here to there. This one I like, where'd my green one go? Here it is. This is my bearing right here. And actually, I'm sorry, this is my bearing right here. I'm comparing all the different pictures. North and east. So that's my bearing right there. And I have to find a way to find it. The problem is, keep in mind, if we look at this, it looks like 62-degree angle is this one right here, but I actually have 2 black lines there. The total angle is 62 degrees. But whatever this angle is right here, this smaller angle, that will be the angle right there that I care about. If I can find that, it'll be alternate interior with this again, and I'll be done. And now I have a way to find it. If I can find this angle inside the triangle, I know the angle from the axis to that edge is 62, so find the difference between them, and I'll get the smaller angle. And then I'll be done. So now, find that angle inside the triangle. I'm going to erase my little picture here so we have room. And let's see, now I have this angle, I have that side, I'm looking for this angle, I have that side, so I can apply law of sines. Sine of 148 over 7.76 equals sine of x over 6. So I get 6 sine of 148 equals 7.76 sine of x. Divide the 7.76. And I get sine x equals that. So now I plug in 6 sine 148 divided by 7.76.4097. And now take the sine inverse. And I get 24.1 degrees. Now that tells me this angle inside the triangle is 24.1 degrees. I know this total angle is 62. I care about the difference between them, so subtract. 62 minus 24.1. And I'll just throw it in here. 37.9. That's this angle, which means it's this angle, which means it's my bearing. North, 37.9 degrees. East. And I do actually stress there are different ways to find this. Again, it's kind of up to you and what you see, how you visualize this, what makes sense to you. This is just one way. I tend to always fall back on parallel lines and interior angles and transversals because that's like the easiest geometry I can come up with. But there are different ways to set this up. And just keep in mind when you're doing this, your bearings are always north-south, then east-west. On some of your homework, you gave me a bearing like east 50 degrees north. That's wrong. Most of the semester and everything we do our angles from the horizontal. When we talk about bearing, it's different. I start with the vertical, north or south, then east or west. If there are any other problems, questions, whatever that you'd like me to go over, feel free to email me and I'll either respond by way of email or I'll make another video if you think that would help.